Huawei Massive MIMO solution is designed to fully utilize the existing sites and spectrum resources and significantly improve the capacity and user experience of LTE, FDD wireless networks. This solution uses multiple independent antennas to implement spatial multiplexing and the same-time frequency resources. Static Multiple Beam (SMB) based on TM4 is a function of this solution. It splits one sector beam into multiple fixed beams to form a sector split group based on the selected beam deployment mode and weight information. UEs, served by different beams, share the same time frequency resources, and TM4 and TM9 UEs can obtain spatial multiplexing gains from static beams. In SMB mode, however, TM9 UEs cannot use CSI-RS beams for measurement and therefore cannot obtain spatial multiplexing gains from UE pairing. Dynamic Massive Beam (DMB) based on TM9 is another function. It dynamically generates UE-level beams, and TM9 UEs can obtain spatial multiplexing gains from UE pairing. In DMB mode, however, TM4 UEs do not support CSI-RS measurement. These UEs are cell-level wide beams and therefore cannot obtain spatial multiplexing gains. Intelligent beam scheduling is developed to offer the optimal gains in scenarios with both TM4 and TM9 UEs. Intelligent beam scheduling provides SMB for TM4 UEs so that they can achieve spatial multiplexing gains from static beams. In addition, it provides DMB for TM9 UEs based on SMB so that they can achieve spatial multiplexing gains from UE pairing. A sector split group served by an AAU is generally allocated a certain power. Assume that the total power is 120 watts and the maximum power allocated to each cell in the group is 30 watts. The power of cell 1 increases with the number of UEs until it reaches the maximum power. If the number of UEs continues to increase, the downlink user perceived rate decreases. In this case, cell 4 has remaining power but cannot share the power with cell 1. Inter-cell power sharing is introduced to intelligent beam scheduling to address this issue. It enables multiple cells in a sector split group to share the transmit power of data channels. Cell 4 can share the remaining power with cell 1, increasing the downlink user perceived rate of cell 1. In addition, inter-carrier power sharing is introduced to intelligent beam scheduling as the preceding situation also exists in the sector split groups served by the same AAU. Assume that the total power of the AAU remains unchanged. If sector split group 1 requires more power, sector split group 2 can share the remaining power with group 1, increasing the downlink user perceived rate of group 1. TM9 beam interference management is used in intelligent beam scheduling to mitigate intra-frequency interference caused by TM9 beams to TM4 and TM9 UEs when the proportion of TM9 UEs keeps increasing. The base station can adjust the strength and direction of traffic beams of interfering UEs based on the interference received by interfered UEs. Fast TM9 enabling is used in intelligent beam scheduling to shorten the delay of entering TM9 and increase the online duration of TM9 UEs. With this function, the base station no longer evaluates the mobility of a UE before the UE transmits from TM4 to TM9, which shortens the waiting delay. That's all about the main functions of intelligent beam scheduling. For details about LTE FDD Massive MIMO, scan the QR code on the screen.